Thank you, John, and thank you to the organizers for putting this together. I hope that the two talks will likewise complement each other. A little bit background on the paper that I will be giving. The majority of this text came out at the end of 2016 in an exchange in the International Journal of Epidemiology. The exchange began with two papers, one by Jan van der Broeke and co-authors, and another by George Davey-Smith and Nancy Krieger, essentially providing a critique of sorts of the potential outcomes framework. And some of the points, as I discussed, I think were quite reasonable with regard to the effect that the widespread adoption of this framework has had on epidemiology and possibly on the sorts of questions that we are posing. And then some of the critique which I disagreed with, which were regarding claims that were supposedly made by those advocating the potential outcomes framework concerning what did and did not constitute evidence for causation or even conceptualizations of causation. So those two papers were followed by a series of commentaries. I provided one of those commentaries, but a number of others did as well, and then responses from Davey-Smith and Krieger and van der Broeke and co-authors. And so I've selected a few of the topics from my commentary to present today. I think the exchange is of interest in of itself. It is somewhat polemical if you actually read through the various texts, and I've tried to remove, for the most part, those elements from the current paper and really just focus on the main points that I want to make and distinctions that want to draw. So the primary intent for this paper is really to clarify the scope of the potential outcomes framework. And as you'll see, I'm not advocating that this is the only approach to thinking about causation. I'd be entirely in favor, for example, of the dualist approach, but to try to clarify what the potential outcomes framework does and does not entail, and the sorts of questions that it's useful to address and not. So with that, I'll begin. And I'd like to structure my remarks around a series of propositions that articulate my views concerning causes, causation, and potential outcomes. So first, a distinction ought to be drawn between conditions under which we can reasonably describe something as a cause versus under which we can reasonably define a quantitative, numerical causal effect estimand. The potential outcomes framework provides an approach to defining quantitative causal effect estimands. So said another way, the circumstances may differ with regard to when we are willing to talk about a cause qualitatively versus when we think it's reasonable to quantify. The potential outcomes framework provides a way to quantify causal effects. And it does so for a particular hypothetical intervention. It defines a causal effect for an individual as the difference between the outcomes that would have been observed for that individual with a particular exposure versus without a particular exposure. And in the potential outcomes notation, we typically denote that by y1 and y0, respectively. To make this definition precise, the potential outcomes framework imposes certain assumptions, such as the hypothetical intervention is sufficiently well defined for the outcome under consideration, and under the considered intervention to be for each individual either unique or to have a unique fixed distribution. The potential outcomes framework provides a set of sufficient conditions for defining a quantitative numerical causal effect, what I'll be calling subsequently a causal estimand. Because the term causal effect itself is somewhat ambiguous insofar as it might be used simply to refer to the effect of some cause, but is often used in a more precise sense within the potential outcomes framework as, again, a numeric quantity that one seeks to estimate from data. So from this point onwards, I will refer to this simply as a causal estimand, but something that is numeric and quantitative. The potential outcomes framework then formally articulates the assumptions under which such causal estimands can be estimated on average or in distribution for a whole population. So when there's an intervention in view, it generally makes sense to speak of causal effects quantitatively. For example, if we're considering the intervention taking pill X, we can consider how much blood pressure might differ for an individual with versus without the pill. Generally, whenever it's reasonable to talk about a specific causal estimand, then provided it is non-zero for some individual, it's reasonable to talk of the hypothetical intervention or the exposure also as a cause. But the reverse is not true. There are many contexts where it might be reasonable to speak of something as a cause, but more difficult to articulate what one means by a causal effect estimand, a numeric quantity. As I'll discuss below, I think it's quite reasonable to say that obesity is a cause of longevity or mortality, but much more difficult to define what precisely one means by the causal estimand for obesity itself. The potential outcomes framework thus does not delimit what is a cause. Rather, it provides a set of sufficient conditions to conceptualize quantitatively causal effect estimands. And I argue below that there are not many satisfactory alternatives for this at present. Quantitative definitions, assumption articulation, interpretation, and effect estimation are, at present at least, I think largely restricted to the potential outcomes framework or those from which potential outcomes can be derived or have analogs such as causal Bayes nets or intervention diagrams. Second proposition. All counterfactuals are vague to a certain extent, but can be made more precise by specifying further the contrary to fact scenario in view. When such contrary to fact scenarios are sufficiently precise, they admit potential outcomes. The potential outcomes framework then provides the conceptual and mathematical link between data and causal effect estimands. So to explicate this further, positions often articulated that all counterfactuals are vague to a certain extent, but they are made more precise by specifying further the relevant contrary to fact scenario or by specifying further what is meant by the counterfactual. And I believe this pertains both to discussions of causal effect estimands, numeric quantities, and also to discussions of causes more generally. And this position has effectively been adopted by those employing the potential outcomes framework. So potential outcomes are always ill-defined to a certain extent, but again, can be made more precise by further specifying the hypothetical intervention or contrary to fact scenario under consideration. The contrary to fact scenario under consideration doesn't necessarily need to correspond to a specific human action, but if it does, it often helps specify further what is meant. However, I think even specifying a hypothetical intervention may not eliminate all ambiguity. So just specifying a human action often is not itself sufficient to eliminate the ill-defined nature of the counterfactual. So for example, if we take a pill X, there may still be questions as to the timing of taking the pill and whether the pill is taken with or without food. And specifying some of these may make the counterfactual under consideration more precise, but some of these aspects may not be relevant for the outcome and thus can potentially be ignored. We can sometimes specify counterfactual outcomes without specifying all aspects of the hypothetical intervention. Conceptualizations for potential outcomes for each individual that follow a distribution rather than a particular value relax the requirements yet further. But the general principle is that the further we specify the hypothetical intervention, the more precise is our counterfactual. And if the hypothetical intervention is sufficiently precise, then we might entertain using, again, numeric potential outcomes. Those with versus without the intervention can then consider causal estimands. However, even if our exposure or hypothetical interventions are not precise, we can still pose counterfactual queries or ask if a particular exposure is a cause. With obesity, for example, the statement obesity is a cause of mortality is vague. One could specify further what is meant, and if someone's queried further as to the meaning of the statement, it might be understood along the lines of if one could reduce the body mass index for those with a BMI of 30 to bring this down to a BMI of 25, then this intervention would result in a longevity benefit for some of those individuals. But that counterfactual is still vague. Any practical way to implement the reduction in BMI, whether by exercise, diet, stomach surgery, or liposuction, may have different effects on longevity. However, if the truth value of every possible interpretation of the more precise specification of the counterfactual were the same, then it might be reasonable to assign that truth value to the ill-defined, imprecise counterfactual as well. In such a case, we might be willing to say that obesity is a cause of longevity, even though formal potential outcomes and thus causal estimands are not well defined. So there's basically a continuum with regard to how well-defined counterfactuals are. I think as is made clear in the example above, the requirements in terms of removing ambiguity for numeric potential outcomes is more stringent than for general counterfactual inquiries or for discussion of causes. Of course, simply writing down potential outcomes notation does not mean that the potential outcomes are well-defined. They're only well-defined to the extent that the hypothetical intervention or contrary to fact scenario is specified. But when it is reasonable to use potential outcomes, the framework provides both a conceptual and mathematical link between the data on the one hand and the causal effect estimands on the other. In actual epidemiologic research, investigators collect data, typically encoded just as a string of numbers. Then a data analyst performs various computations on these data strings. Based on those computations, the investigators may produce written or verbal sentences concerning causal relationships. But the relationship itself between the strings of numbers and the resulting sentences needs a formal framework for translation, and the potential outcomes and related frameworks provide that needed formalization. There's now an entire mathematical calculus for reasoning about potential outcomes based on causal diagrams or directed acyclic graphs, for example. In some settings, such as is the case with effects of exposures that vary over time, adequate methodology required to assess such effects arguably could not be carried out without the sort of formality that the potential outcomes and related frameworks provide. It becomes a lot more difficult when we look at an exposure that changes over time, when our confounders change over time, than just when we're looking at an exposure at a single point in time and trying to assess its effects. There, the intuition of just ruling out all common causes works pretty well. The potential outcomes framework formalizes that approach, but the intuitive approach was quite effective. But once we have moved to time-varying exposures with time-varying confounders, intuitions have often broken down, and that formalization has been important. Likewise, certain questions about mediation, about mechanisms and indirect effects, when assessed quantitatively, for these it was thought for a long time, at least in practice, that a simple regression approach was sufficient, but that turned out to be subject to far more pitfalls than previously realized. Again, insights, I think, made possible through the potential outcomes framework and causal diagrams, and that's much of what I discuss in my book as well. And I believe these are really major advances over what was available previously, and I believe lies at the heart also of the current interest in these methods based on potential outcomes. Thus, while I believe that the sort of causal diagrams and counterfactual approaches are only one set of conceptual tools that epidemiologists can employ, and shouldn't occupy a privileged place in delimiting the kinds of questions we ask or causes that we theorize about, I do think that potential outcomes and related approaches have a privileged position in the estimation of causal effect estimands. So not in all of causation, but in terms of numerically trying to quantify effects. Third proposition. Some progress has been made in defining causal effect estimands for settings which lie outside of the traditional potential outcomes framework, but this continues to remain challenging. So when we move to try to talk about causal effects for what we might call composite exposures, those which don't correspond to a single hypothetical intervention, exposures like obesity or cholesterol, I think precisely interpreting what is meant becomes more difficult. The potential outcomes framework is not as obviously applicable to such composite exposures. If one tries to frame the effect of morbidity on mortality within the potential outcomes framework, it becomes clear that different interventions to reduce obesity, again, diet, exercise, surgery, may well have different effects on mortality. It thus becomes difficult to speak of the causal effect estimand comparing a BMI of 30 versus 25. That's not to say that obesity is not a cause, but rather that trying to give an estimate, a precise interpretation, is challenging. Some research has addressed such questions by extending the potential outcomes framework so as to include multiple versions of the exposure or intervention under study. So under various assumptions, the estimate of a composite exposure, such as obesity, can be conceived of as a weighted average of the effects of different, more precise versions of the exposure, weighted by the likelihood of each version naturally arising within the subpopulation that was actually exposed. However, the meaning of such an interpretation is difficult when the underlying distribution of the kind of versions of treatment, the different ways that obesity came to be 35 versus 25 is unknown, and that's often the case. We don't know all of the paths that brought people to the current level of BMI that they were at. Moreover, the known measured confounding assumptions required for this interpretation are difficult to assess when the different underlying versions of the exposure are unknown. Some progress has thus been made in providing a more precise interpretation of the causal effect estimands for such composite exposures, but whether and how such interpretations are helpful in practice, as I would say, is not yet entirely clear. Judea Pearl has proposed that a causal effect estimand of a composite exposure be viewed not as the effect of a hypothetical intervention, but as an effect arising from an underlying structural equation model. An analogy he draws is made with the laws of nature, whereby the exposure, the state of the universe, and the underlying laws suffice to set the outcome or its distribution. If the exposure were different, the outcome would be as well. So within the framework of these causal diagrams or structural equation models, the structural equation itself essentially takes the place of the underlying laws of nature. And while such an interpretation is promising in principle, I think its use in practice is problematic. First, unlike in the physical sciences, in the social and biomedical sciences, the complexity of the systems studied are such that we are almost never in a position to articulate a causal diagram that would adequately capture the natural laws. Second, even if we could, when we have composite exposure in view, many of the constructs we use in the social and biomedical sciences are not sufficiently precise so as to be a part of the underlying laws of nature. If, for example, if we're considering the effect on mortality of a change in BMI from 30 to 25, the fundamental underlying laws that result in death are such that there's not a one-to-one mapping from BMI to all of the relevant variables governed by the natural laws. So implicit within the proposed structural equation model interpretation is that it's possible to conceive of the exposure being different, but all else within the system being the same. And with many of our composite exposures, this just isn't possible. This doesn't mean that causal diagrams are irrelevant. I think often a simplified diagram can help diagnose bias in a way that if one can see it on the simple diagram, it would also be present on any more adequate representation of reality. But it does mean, again, I think that we cannot talk about causal effect estimands if it's the case that every possible mapping from BMI to the underlying relevant variables implied by a change in BMI from 30 to 25 resulted in mortality. We could perhaps still talk about causes if each of those potential changes, again, corresponded to a effect on at least some individuals. We could still reasonably speak of obesity as a cause, but it becomes more difficult to talk about a causal effect estimate. So again, perhaps the best we can do in these settings is to appeal to what is still a somewhat vague interpretation under a theory concerning multiple versions of treatment or exposure as described above. Thus, although the approach to conceptualizing causal effects of composite exposures through underlying structural equation models is theoretically appealing, I think this interpretation is still difficult in practice, and I've not yet seen a compelling empirical example. The potential outcomes framework, I think, begins to reach its limits when we start talking about effects of such composite exposures. It points the researcher to precise hypothetical interventions which do not necessarily correspond to the complexity of some of the exposures that we study. And so I think responses to this challenge may vary. If policy intervention or action is of interest, then I think the potential outcomes framework is actually helpful in thinking through what are a range of realistic interventions that might alter the composite exposure and also try to best improve outcomes. So it can help restrict our thinking to what is actually possible to do in practice. One can, again, I think, alternatively try to pursue one of these more nuanced interpretations, as in the proposals above concerning multiple versions of the exposure, or one could abandon any attempt at precise interpretation of a quantitative estimand and then simply speak of evidence for causation generally or something being a cause. So one can certainly criticize or complain that the potential outcomes framework does not adequately address questions of such composite exposures, but I think this simply amounts to a complaint that the tool does not address questions for which it was not intended or that are even well defined. Nor do complaining about that, as was the case I think in several of these papers in the International Journal of Epidemiology, they don't really help in any way provide a precise interpretation of the effects of these composite exposures. I still would maintain that what little progress has been made on trying to interpret the numeric quantitative causal effect estimands has in fact come out of extensions of the potential outcomes framework or causal diagram frameworks. Fourth proposition. Although policy should be informed by many considerations, not just causal effect estimands, these estimands from causal inference using potential outcomes, I think, do have a central role in deciding between policies and interventions based on the quantification of causal effects. But I do entirely acknowledge that there are important questions that are not amenable to the potential outcomes framework. So again, I think perhaps a more reasonable and profound complaint in these papers in the International Journal of Epidemiology, so suggested by both WANDERWEELE et al. And Krieger and Davey-Smith, and also in another recent article by Schwartz and co-authors, is that the potential outcomes framework itself is restricting the types of questions that we're posing. So as alluded to above, simply this follows from the complexity of the systems or exposures being studied. So Krieger and Davey-Smith, for example, make reference to social movements, societal trends such as more married women going to work, and even sort of the occurrence of war. These are important things that shape population health outcomes. But with these questions, the complexity of the exposures or systems under study compounds even further the issues that had previously discussed. The potential outcomes framework simply is no longer the right tool. There is no single intervention, for example, that corresponds to the civil rights movement in the United States. Other modes of inquiry and evaluation are then needed. There are subfields of history, for example, that do attempt to address these questions. In complex settings concerning wars or social movements, even if data are aggregated over many wars, say, the precise meaning of the counterfactual queries is very ambiguous, as again discussed above in the second and third proposition. So if epidemiologists want to and are successfully able to address these questions concerning individual historical events, I think that's fine and that's good, but these require very different disciplinary tools and different data than epidemiologists typically have at their disposal. These are still counterfactual queries of a sort, what would have happened without the civil rights movement, but of a very different nature and ones which are often more difficult to answer. I do, however, think the potential outcomes framework can again be useful in narrower policy evaluations and decisions. When various actions are being considered rather than explanation, it can be helpful articulating what precisely is under study, the data and assumptions needed to estimate the effects of specific actions, and can thereby provide guidance on the relative magnitudes of those effects and to choose between actions. So I think arguably a great deal of the popularity of the potential outcomes approach within epidemiology has come about because of the precision the framework offers and its success in evaluating numerous types of causal questions concerning effect estimands. However, as suggested by both WANDERWEELE and co-authors and Krieger and Davey-Smith, that very success may well have led to a shift in focus in the types of questions that are even being asked those questions which are not amenable to a potential outcomes analysis are perhaps receiving less attention than they had before. And again, as noted by Krieger and Davy-Smith, some of these questions are of tremendous societal importance. So the solution, it seems to me, is not an attack on or a caricature of the potential outcomes framework, but rather ensuring that within teaching and in the published literature, there are more examples of broader questions concerning systems and movements, and that these are discussed along with examples of where other types of reasoning and evidence have, in fact, proved useful, as I think you saw in the last presentation as well. Causal inference using potential outcomes are but a small subset of the courses that are offered in most departments of epidemiology or schools of public health. This material can and should be covered concerning these broader questions in other courses, and this, of course, is already happening at many institutions. Fifth proposition, although no complete characterization of causation is yet available, there are well-established sufficient conditions for attributing causation, and the potential outcomes framework provides one such set of sufficient conditions. While the open questions on causation are important, this should not be used to obscure the progress that has already been made. So as noted in the papers by both van der Broeke et al. And by Krieger and Davy-Smith, there are ongoing discussions in the philosophical literature concerning the nature of causation with different conceptions put forward. I think no complete characterization of what is meant by causation is yet available. In particular, I think there is not yet any complete characterization, in other words, a set of necessary and sufficient conditions for the statement X caused Y. Although we can often come to consensus in any given instance, and perhaps seemingly do so according to some unspecified set of rules, no one to date has yet been able to precisely articulate those rules. This does not, however, mean we cannot sometimes, perhaps even often, reason about causation. Although there's perhaps not yet a complete characterization, I think there are sufficient conditions under which we can attribute causation. In particular, I believe there would be near universal consensus that if it were the case that a particular event X, along with the current state of the universe and the laws of nature, entailed some subsequent event Y, and if the absence of event X, along with the current state of the universe and the laws of nature, entailed the absence of Y, and if X and Y were in fact present, then almost all would say X caused Y. These are not the only circumstances in which we would say X caused Y, but they are sufficient conditions for our saying so. This is a type of relationship of counterfactual dependence. That such counterfactual dependence is not necessary, again, I think it is sufficient, but it's not necessary for attributing causation, can be made clear by so-called cases of overdetermination. So an example that's sometimes used, an explorer is going to go on a journey in the desert. His water supply is poisoned by enemy number 1, but then it's subsequently completely emptied by enemy number 2. The explorer goes off into the desert and subsequently dies from dehydration. We would generally say that the emptying of the water caused the explorer's death, even though the explorer would still have died by poison had the water not been emptied. So again, we would still say the emptying of the water caused the explorer's death, even though there's no longer counterfactual dependence on that event, because had the water not been emptied, the explorer still would have died by poison. In any case, the potential outcomes framework effectively takes the event X and the sufficient conditions above as some sort of hypothetical intervention. The outcome differs depending on whether the intervention is present or absent, then the intervention is said to have affected the outcome for that individual. The potential outcomes framework thus provides a sufficient condition for attributing causation. However, like all approaches to date, it does not provide a complete characterization of causation. It does not delimit the bounds of causality. It is concerned with a subset of causal questions that can be defined as a contrast of hypothetical interventions, and again, as above, essentially the only one, I think, for thinking quantitatively and numerically about causal effect estimates. Sixth and final proposition here. While it may not be unreasonable to claim that race is a cause of health and of other outcomes, it still remains difficult precisely to define what one might mean by a quantitative, numeric causal effect estimand for race. Nevertheless, I think counterfactual-based methodology concerning how much of a racial inequality could be reduced by potentially implementable interventions constitutes an important approach to understanding how best to reduce disparities. So there have been recent disputes in epidemiology about whether race is a cause. And in these discussions, I think it's again important to distinguish between the conditions under which it's reasonable to speak of something as a cause with the conditions under which it's reasonable to give a causal interpretation to a numeric effect estimand, as in the first proposition above. When it comes to talking about a numeric causal effect estimand for race, I think this becomes more difficult. And it's this task of considering under what conditions one can provide a precise causal interpretation of race, or of regression coefficients for race, or of aspects of race and racism that has occupied some of the potential outcomes literature on race. Much of this work concludes that such interpretations with respect to race itself, while perhaps not impossible, are difficult, as per the second and third propositions in this paper. However, to claim that such research is therefore asserting that race is not a cause is again to confuse when it's reasonable to speak of something as a cause and when it's possible to interpret a numeric causal effect estimand. One might say that race is a cause in the sense that whatever might be meant by race, or however one might define or conceptualize race, that conception would entail also certain features such as skin color, and that these themselves are perceived by others and, as a result of discrimination, affect health, income, and other outcomes. One might thus maintain that under any reasonable conceptualization of race and any reasonable conceptualization of causation, race satisfies sufficient conditions for attributing causation. Essentially, that the truth value of race is a cause of health is the same irrespective of the how the causal claim is interpreted or further specified. Making such statements is thus perhaps not unreasonable, but still does, again, not supply an interpretation of numeric causal effect estimands. I think a more helpful approach, however, is trying to more precisely specify the claim or claims that may actually be in view and how those relate to policy goals and objectives. In some of my work, I've written about methodology whereby race coefficients in regression models that include covariates, such as childhood socioeconomic conditions, or potentially mediating variables, such as secondary school education achievement, can be interpreted as by how much a racial inequality could be reduced and how much would remain under hypothetical interventions to equalize the distribution of certain covariates, like childhood socioeconomic conditions or, say, subsequently educational attainment. If those were equalized across racial groups, how much of the disparity would remain and how much would be reduced. And I've argued that analyses and interpretations can perhaps be useful in identifying what sorts of interventions would be most effective in reducing disparities. This methodology avoids claims about the causal status of race as it focuses on observed differences in outcomes across racial groups and how these would change under various interventions on other variables. The methodology does not somehow implicitly assume that race is not a cause. The use of the methodology does not imply that we should ignore broader societal factors such as social movements or racial discrimination. Rather, in keeping with the potential outcomes thinking, the methodology focuses on a set of questions concerning interventions that might reduce racial inequalities. I would argue that for purposes of not simply documenting and understanding, but addressing and reducing racial disparities, such methodology is of use. Questions concerning race and racism certainly should be addressed by tools other than the potential outcomes framework, but even here I would argue the framework is of value for a number of policy-relevant questions. In summary, I've attempted here to state more precisely my own views on issues of causation, causal effects, and potential outcomes. I've drawn a number of distinctions and have put forward a series of propositions that I believe are helpful in reasoning about causation and causal effects and their distinction. My hope is that these distinctions and propositions are of use to epidemiology, but that they might also allow for a contribution from epidemiology to discussions on the philosophy of causation. Thank you.